So for this first one, we're solving for x, and x is in the exponent. So anytime that we have x in the exponent, the reason we're going to use logarithms is because one of our log laws says that when you have log of a power, that exponent can come out in front. And what that'll do, like if I have log 2 to the x, then that x can come out in front. And what that does is it takes the x in the exponent where we feel like we can't solve for it and brings it out in front and changes it to an equation that we're used to solving. So the very first step that we're going to do in these situations when we see the x in the exponent, we've done some already where we could change both sides to the same base. But this one with a base of 2 and the other side is a base of 3, you can't do that. So then you're going to take the log of both sides as the first step, because it's still an equation. So what you do to one side of the equation, you do the other, and this is still a valid step. Now our log law says this x can come out in front, and we have to recognize that log of 2, log is a function, log of 2 and log of 3 are just numbers. So at this step, when I have x log 2 equals log 3, it's very similar to the question that would be x times 2 equals 3. It's just harder to see that it's the same type of question because the numbers don't look as nice. Log 2 as a number doesn't look as nice as 2. But what would you do here? You divide both sides by 2. So what do we do here? We divide both sides by log 2. And you get log 3 over log 2. Now when we go to our calculator and type that in, log of 3 divided by log of 2, we get 1.584. And what we're going to do a lot of times with these numbers, I'm going to store this one into memory as x. And then the nice thing about our exponential equations is you never have to flip to the back of the book to see if you're right. You just plug your answer in and you'll know right away on your test whether you got your question right or whether you have to go back and see where you made a mistake. Because this question was asking, what is 2 to the power x? And if I plug that in, I should get 3. And since I did, I know that my answer was right at 1.58. 1 second. So we've got our equation here where we solved it by taking the log of both sides. Now, you can take the log on both sides of anything. So you could have, at the very first step, taken the natural log of both sides as another way to do it. Now, all the steps are going to be the same because natural logs and logs have the same rules. So they come out in front. And then you divide both sides by natural log of 2 because that's a number. And if you check this on your calculator, you'll see that if I'd use the natural log button, I get the exact same answer. Now, being efficient, looking at our original equation here, as far as time that this takes, this technically saves me maybe half a second, because every time I write log, I write 3 letters. Every time I write natural log, I write 2 letters. So maybe it's a little bit more efficient. There's going to be some where you have to write log maybe 20, 30 times. So they might even be more efficient to use the natural log. So there's a second way of doing that one. You could have taken log of any base of both sides. So another option would be taking log base 2 of both sides, if you wanted to. Now, what happens here is when the x comes out in front, it seems to be very much the same, but log base 2 of 2 is equal to 1. So this just becomes log 2 of 3, And maybe that another way of looking at this is saying I could have just used the definition of a logarithm to begin with. And the definition of a logarithm says the 2 is my base, x is the answer because that's the exponent, and I could go from the definition of a logarithm right to that. Now, as far as what we're going to be doing, we're going to be using either the first thing we did here where we take the log of both sides or the natural log of both sides. I'm going to consider those equivalent. I'm going to say I'm going to take the log of both sides, and sometimes I'm going to use log and sometimes I'm going to use natural log, just so that you get used to that those are the same. But generally we're going to be using the first two. If you see that you could change it to log base 2 right away and your calculator allows you to type those ones in, that is the fastest, but it won't work in all situations, so that's why we tend to like the first two. So again, we see that we're solving for x. X is in the exponent. And I can't make everything as a base 3. So I can't use the old techniques of trying to get everything to the same base. So when that's the case, we're going to take the log of both sides. This time I'll use the extra letter log one instead of the natural log. So first step, taking the log of both sides. And now is a process of using your log laws until you can get that x by itself. Now the thing that you're going to be most tempted to do, since you see the x as the exponent, is you're going to want to bring that x out in front right away. You have to be careful here, because that log law with the exponent coming out in front is only when that exponent is to the entire thing inside the log. And at this point, the x is just to the 3, not to the entire thing. So what we're going to do is we're going to say, well, this is multiplication. I do have a log law for that. That I can say when you're multiplying, it's the same as adding. And now I can bring out that x in front, because that x is only to that power. Again, if we think log 2, log 3, and log 5 are just numbers, all we need to do is get the x by itself. I'll start by subtracting log 2 on both sides, and then I'll divide both sides by log 3. Again, we're going to go to our calculator. Good to use the fraction function if you have it. We had log 3 minus log 2, is that right? No, log 5. Log 5 minus log 2. Over log 3. Again, I'm going to store that answer and then check back to my original equation, which was 2 times 3 to the x, 2 times 3 to the power x, and see if it's equal to 5, which I wanted it to be. So again, it's very nice that you can plug things in to check to see if they're right.